This is the first part of this video, and this is our problem framing 1. So we have 25 number of participants, and programming language with 3 levels as a grouping variable. And we have accuracy as a dependent variable. So to do one way on ANOVA, we click on ANOVA tab, and click one way on ANOVA. We have to put the programming language in the grouping variable, and accuracy as a dependent variable. And check the descriptive table to get the means. As we can see the results, the F value is 54.6, the DF1 value is 2, the DF2 value is 14.6. And the p-value is less than 0.001, which is less than 0.05. So we can assume that there is a significant difference in debugging accuracy among the 3 computer programming languages Python, Java, and C. Next step, we have to go to the correlation matrix, go to the regression tab, and click the correlation matrix. We have to put all the variables into the .right box to see the results. As we can see, our value is equal to 0.040. And the p-value of the correlation matrix is 0.848, which is more than 0.05. So we can assume there is no significant relationship between programming language and debugging accuracy. So this is the second part of our video, and this is our problem framing 2. So as you can see in our data, it has the same number of participants as part 1, and the same grouping variable that has 3 levels, but the difference is that time minutes is now the dependent variable in part 2. And the procedure to see the results is exactly the same as part 1. Go to ANOVA tab, and click one way on ANOVA. We need to put the programming languages in grouping variable, and time minutes in the dependent variable, and check the descriptive table below to see the mean results. As we can see, the F value is 131, DF1 value is 2, DF2 value is 14.6, and the p-value in one way on ANOVA is less than 0.001. which less than 0.05. So we can assume that there is a significant difference in debugging time among the computer programming languages Python, Java, and C. Next, we have to go to regression tab and click correlation matrix and put all the variables in right side box. Now we can see the results of correlation matrix. We can see our value is minus 0.012, and p-value in correlation matrix is 0.955, which is more than 0.05. So we can assume that there is no significant relationship between programming language and debugging time. This is the last part of our video. And this our problem framing 3. As you can see, we 25 participants, same as in part 1 and 2, and a programming language with 3 levels as a grouping variable. But the difference is that confidence level is now the dependent variable in part 3, and the procedure is exactly the same as the previous parts. Go to ANOVA tab and click one way on ANOVA. We need to put programming language in the grouping variable and confidence level in the dependent variable, and hack the descriptive table below to see the mean results. Now we can see the F value is 69.6, DF1 value is 2, DF2 value is 14.5, and the p-value in one way on ANOVA is less than 0.001, which is less than 0.05. We can assume that there is a significant difference in confidence levels among students using the computer programming languages Python, Java, and C. Next step is to go to the regression tab and click the correlation matrix and put all the variables into the right side box. Now we can see the R value is equal to minus 0.024. And p-value of correlation matrix is equal to 0.908, which greater than 0.05. So we can assume that there is no significant relationship between programming language and student confidence level.